Welcome to Factors. Before we get bogged down in any formulas or rules, I want you to just think about this fundamental question. What numbers divide evenly into another number? Really let that sink in for a second. Divide. Evenly. This simple idea of breaking a larger whole into perfect, equal parts, that is the absolute heart of what we're learning today. Understanding basic factors. Okay, so let's clearly define our terms here. A factor is a number that divides another number exactly, with absolutely no remainder. And I really want to emphasize those last words, exactly and no remainder. If you divide a number and you end up with a decimal, a fraction, or any leftover pieces, well then the number you divided by is simply not a factor. It has to be a perfectly clean cut. And this brilliantly illustrates that exact concept. Look at these blue blocks. If we have 6 blocks, we can divide them by 1, right? We get one long row of 6. We can divide them by 2, which gives us 2 even rows of 3. We can divide them by 3, giving us 3 perfect rows of 2. Notice how there are literally no leftover blocks in any of these setups? Because of this, we know for sure that 1, 2, 3, and 6 itself are all factors of 6. And notice how we didn't bother trying to divide by 4 or 5. That's because you'd end up with awkward leftovers, and factors don't do leftovers. Finding factor pairs. Now, here is the crucial shift in our thinking. A factor pair consists of 2 numbers that multiply together to make a given number. This establishes the vital mathematical link between division and multiplication. Really, they're just 2 sides of the same coin. Think about it. If 12 divided by 3 is 4, then 3 times 4 is 12. Factors love to hang out in pairs. We're looking at the factor pairs for the number 12. Pair 1 is 1 and 12 because 1 times 12 is 12. Pair 2 is 2 and 6. And pair 3 perfectly locks together 3 and 4. To make sure you never miss a hidden factor, I'm going to guide you through a foolproof 3-step process. Step 1, always start by looking for factor pairs, rather than just isolated numbers. Step 2, check your numbers in strict numerical order. Start with 1, then test 2, then test 3, and so on. And step 3, stop testing the moment your factor pairs begin repeating backwards. Let's actually see this in action. We start with 1 times 18. Then we check 2. Yep, 2 times 9 works. We check 3. Yes, 3 times 6 works. Now we check 4. Nope, doesn't go evenly. 5. Nope. Then we hit 6. But wait, we already have 6 from our 3 times 6 pair. That repetition right there is our signal to stop. We've found them all. Special rules and exceptions. So, there are some absolute universal truths when it comes to factors. First up, the number 1 is always a factor of every positive whole number, always. Second, the number itself is always a factor. This means every whole number greater than 1 has at least 2 factors automatically, right out of the gate. And finally, here is a strict exception you've got to remember. 0 is never, ever a factor of a positive whole number. You simply cannot divide by 0. Let's actually prove that these rules hold up perfectly in practice. Take the factors of 15, for example. 1, 3, 5, and 15. Notice the bookends there? 1 is there, and 15 is there. Now compare that to the factors of 20. 1, 2, 4, 5, 10, and 20. Again, 1 and 20 are the outer anchors. And, predictably, 0 is nowhere to be found on either list. See, the rules work every single time. Factors in real life. I know what you might be thinking. Why does this matter? Well, imagine a teacher organizing a classroom. They have exactly 24 students, and they want to set up desks in perfectly equal rows so nobody is sitting awkwardly alone at the back. How can they do it? Factors are literally the answer. By knowing the factors of 24, the teacher knows all the possible seating arrangements. They could do 1 row of 24. They could do 2 rows of 12. They could organize 3 rows of 8 or 4 rows of 6. Factors aren't just abstract numbers on a page. They're the practical, mathematical tools we use to organize groups, share items equally, and solve everyday spatial problems. Practice and review. Now it's your turn. Can you find all the factors of 10? What about 16? And what about 21? Think back to our steps. Start with 1 and the number itself. Move systematically, and stop the second you repeat a number. Let's reveal how you did. For 10, the factors are 1, 2, 5, and 10. For 16, you should have 1, 2, 4, 8, and 16. Notice that 4 pairs with itself there, which is totally fine. And for 21, the factors are 1, 3, 7, and 21. If you got those, fantastic work. Now for the ultimate challenge question, what is the greatest factor of any number? The answer? The number itself. It's physically impossible for a factor to be larger than the number you're actually dividing. Let's quickly summarize our core takeaways today to really lock everything into long-term memory. We learned that a factor divides a number exactly. We learned that factor pairs multiply to make the given number. We saw that every number always has 1 and itself as factors. And we proved that this isn't just theory. Factors actually help us solve real-world grouping problems. So the crucial point is making sure we can actually spot the right answers when we're tested on this. Let's do one final quick check. What are the factors of 14? Look closely at those options. Option C is incomplete. Option B lists numbers that are larger than 14, which completely breaks our rule. Therefore, it has to be option A, 1, 2, 7, and 14. Which brings us to the end of today's incredibly focused explainer. But before we go, I want to leave you with a provocative thought to chew on. If factors are how we break numbers down into smaller parts, what happens when we use them to build numbers up into a massive, infinite sequence? We are going to explore exactly how numbers grow like that in our next explainer on multiples. Until then, keep practicing, keep your numbers organized, and thanks so much for learning with us today.